Hello students, welcome to my channel. I am Sridhar here. Today we learn about inert pair effect and potash alum in the lesson P block element. Before go to the learning process, subscribe the video by clicking the subscription button. Thank you. Inert pair effect. What is inert pair effect? In heavier post-transition metals, the outer s electrons ns have a tendency to remain inert and show reluctance to take part in the bonding, which is known as inert pair effect. You are seeing a picture 13th, 14th, 15th, 16th group P block elements. These are the post-transition elements. The above definition, you see the first line, heavier post-transition metals. This is the post-transition metals, which is called heavier post-transition metals. The last two series are known as heavier post-transition metals. These are showing higher inert pair effect. So among these groups, the inert pair effect increases from top to bottom. It means aluminium has less inert pair effect than that of thallium. What is the general outer electronic configuration of these P block elements? Ns2, Np1 to 4. I highlighted the 2 electrons present in s orbital. Those 2 electrons are inert. I highlighted the higher inert effect showing elements. They are shown here. Inert pair effect. So these 2 series are showing higher inert pair effect. The first series, indium, tin, antimony, tellurium, having d electron in the inner orbital. Thallium, lead, bismuth, polonium, these series are having d as well as f electrons in the inner orbital. So consider a nucleus. So nucleus are having protons, therefore positively charged. You see a outermost orbital contains 2 electrons of s orbital because the s electrons showing inert pair effect. I am not present p electrons because in inert pair effect the p electron is not come into the picture. In between nucleus and the outermost orbital, there is a inner orbital. That inner orbital has d electrons or f electrons. See here. These inner d as well as f electrons are having poor shielding effect. Because of this poor shielding effect, nucleus attract the outermost s electron effectively. Therefore, the 2 s electrons are strongly bounded to the nucleus. Therefore, the 2 electrons are unable to form chemical bonding. The 2 electrons are inert in nature. So that the 2 series are showing higher inert pair effect due to the poor shielding of d as well as f electrons. You see the notes for this. Due to the poor shielding of inner f and d electrons, the outer s electrons come into the influence of the nucleus and more tightly bound to the nucleus, hence do not take part in the bonding. Next, potash alum. K2SO4 dot Al2SO4 thrice dot 24H2O. Point number 1. The alunite, the alum stone, is naturally occurring form and it is having the formula K2SO4 dot Al2SO4 thrice dot 4AlOH thrice. When alum stone is treated with excess of sulfuric acid, the aluminium hydroxide is converted into aluminium sulfate. You see here, this is a alunite stone which has the formula K2SO4 dot Al2SO4 thrice dot 4AlOH thrice. It is treated with excess of sulfuric acid, H2SO4, gives potassium sulfate, aluminium sulfate and water. So the reaction is over. The reaction is unbalanced. How to balance? Listen, we have 4 aluminium, 2 aluminium, 6 aluminium. Therefore, in front of aluminium sulfate in the product side, make 3. Now you see sulfate in the product side, 3 into 3, 9 plus 1, 10. Therefore, in the reactant side, we have 1 sulfate, 3 sulfate, 4 sulfate. In front of sulfuric acid, make 6. Now, sulfate is balanced. Now, hydrogen, 12 hydrogen plus 3 into 4, 12. 12 plus 12. 24 hydrogen there in reactant side, therefore make 12 in front of water molecule, the product side. Now the equation is balanced, very easy. Point number 3, a calculated quantity of potassium sulfate is added and the solution is crystallized to generate potash alum. Why you have to add potassium sulfate? You see the above equation. We have 3 sulfate. In potash alum formula, we have only 1 sulfate. Therefore, in solution, excess of aluminum sulfate is that. Therefore, add a calculated quantity of potassium sulfate and crystallize. You get potash alum. Any impurity is present in potash alum means you go for recrystallization. Thereby, we purify potash alum. Next is burnt alum. What is burnt alum? At 475 Kelvin, potash alum loses water of hydration and swells up. The swollen mass is known as burnt alum. What is the equation? Potash alum at 475 Kelvin loses water of crystallization to give burnt alum. This is the equation. Now you can compare both. Potash alum looks like this. Burnt alum looks like this. So what is the difference between these two? The difference is only 24 water molecule, which is present in potash alum, which is not there in burnt alum. I hope you understood clearly about burnt alum. Next, 2 questions. First one, which does not show inert pair effect? Options are aluminium, tin, lead, thallium. Question number 2, which is likely to show inert pair effect? Options are potassium, magnesium, aluminium, lead. So answer the question in the comment box. I hope in today's video you learned very clearly about inert pair effect, why inert pair effect is high in heavier post-transition metals, potash alum, burnt alum. If you like this video, share, comment, like. Don't forget to subscribe. We meet soon again in another video shortly. Until then, bye.